This is the spectra of the continuous white light source at the top of that light tower. This is an incandescent lamp. Now, if you looked at the spectra of the fluorescent lights on the ceiling, it wouldn't work because they do not have a continuous spectra. They're a different technology. But old school incandescent lights simply work by heating an element. It's a black body spectra. And you are familiar with this perhaps from your astronomy or other chemistry or physics classes. So what we want to do here is measure the brightest part of the spectra. What is the highest part of that little hill on the graph? That corresponds to the peak wavelength of emission, and you will put that into the formula for Wien's displacement law. You'll put that into the formula in your lab manual to calculate the temperature. Now, what kind of number should you expect? Well, on the one hand, keep in mind that it has to be a high enough number to explain why your easy bake oven that you may have had as a kid actually baked. It has to be pretty high for you to be able to cook a cake with a light bulb. But on the other hand, if you get an answer that's as high as the temperature of the sun, then you're probably a little high. Okay? So you should get a reasonable number. Just input this measurement into the formula in your lab manual. Keep in mind that what you are looking at is nanometers. So what does that mean? That means that if you said the peak wavelength was at 400 nanometers, which it's not, that would be 400 times 10 to the negative 9 meters. So you just want to be aware of your measurements as you use the formula in your lab manual. If you're not sure, please be sure to talk about it in your group.